Now we want to start talking about some of the numerical values you could get as results for experiments. We're going to touch base about scientific notation. Whenever you do an experiment, you're going to get two types of data, qualitative and quantitative. So say your daughter says that she is sick, she feels like she has a fever, and so you would test that by performing an experiment. You could do things that are qualitative, looking at some sort of, kind of qualitative, some sort of quality, like her forehead feels hot, right? That's qualitative data. There's no number or value associated with it. Quantitative data would be actually taking her temperature, right? Temperature is 101 degrees Fahrenheit. So when you perform experiments, both types of data are collected and both types of data have their purpose. For qualitative data, that's more, kind of observational skills or kind of writing skills, those sorts of things. But quantitative data is all numerical. And so we're going to talk about how we deal with those numbers that come out of experiments. It's important to note that all those values have two things. They have a value and a unit. So we'll talk a little bit about values, and then we'll talk a lot about units. Before we get into all that, I do just want to touch base about the idea of exponential notation, which is also called scientific notation. So theoretically, this is something we already have, but I want to make sure we're all on the same page. In the world of chemistry, it's not uncommon for us to get numbers that are really, really big or really, really small. So for example, 1 penny, so contains this many atoms. And that number is very, very large. You could sit there and count zeros to figure out how big it is and then look up what that word means, but it really wouldn't be meaningful. So we use scientific notation to, one, make it easier to write this number down and make it easier to just digest when you read it. So we take a really big number, say something like this, and we represent it instead with scientific notation, 2.95 times 10 to the 22nd power. And these two descriptions represent the exact same value. The motivation behind using scientific notation is because it's more condensed, it is less likely that you will make an error when doing arithmetic or doing calculations with that value. If you tried to type out all of these zeros, it is very likely that you would make a mistake, just because that's a lot of zeros to type in. If you have, say a small % chance of mistyping on each one, do it 20 times, you're going to lose a lot of zeros potentially, or at least 1 zero, which could throw off your answer. And so we really want to use the scientific notation. So when we're using scientific notation, the general goal is our format is that we should have a value multiplied by 10 to some exponent. And the value that we're multiplying by 10 should be between 1 and 10. We want it to be one digit in front of the decimal. So for example, 354. So we have 354. That number isn't too hard to deal with, but we can still convert it into scientific notation. And basically how we can think about it is what we do is we know the decimal is right here, right after the 4. And basically we want it to be after the 3. So we have to move it once, twice. And so that would be the same thing as times 10 times 10, or basically pulling out a 10. So 354 is the same value as 3.54 times 10 to the 2nd power. And we can see that you can figure this out. You don't necessarily have to be doing division. You can just be counting those shifts in the decimal place, right? We did 2 shifts, there's 2 tens. You can also use this for numbers that are smaller than 1. When numbers are really smaller, much smaller than 1, we have the same issue. If you're writing out all of these zeros, it is likely that you will make a mistake. So what we can do is we can think about shifting it, again, to have it represented with, say, 7.2 instead of all the zeros. And so we count 1, 2, 3, 4. So there's 4 shifts that we needed to go and to get the decimal point after the 7. And then we take that 4 and we just put a negative in front of it. So we put a negative in front of it. Sometimes people talk about counting zeros. And you can do that here. You just want to be careful. When you're doing negative, it's going to be, if you counted zeros, you would have gotten 3. And you will note the 4 is 1 more. So counting zeros works with when the number that you're turning into scientific notation is greater than 1, a big number, you can just count zeros, but you can't do that here. You need to count zeros and add 1 more, which is, you can do that. Okay, first video of this set. We will have a participation assignment for this set of videos. So participation 6-2, it's due Tuesday, June 2nd over on Blackboard. And so it's right beneath where you see these videos, the links to these videos. That's where you'll find the link to the participation assignment. That's all due Tuesday at midnight. Tuesday at 9 a.m. We'll have on-campus lab. So that will be we'll come into the room 124 in the science building. We'll start in there, or maybe go some other places, but we'll start in there. Make sure you wear your closed-toed shoes and have your legs covered, part of the lab kind of dress code. And then also recommend, not required, but recommend a sweatshirt. It's very cold in there. And then also the introduction discussion board is due over on Blackboard on Wednesday evening. And then we'll have stuff later this week, a second lab on Thursday, some more lecture videos on Thursday and Friday. If you have any questions about anything, don't hesitate to reach out. Otherwise, we've got to keep watching videos to find some questions for our first participation assignment. I'll see you in the next video. Bye.